So let's tackle now problem 1. So for this one, this is the case 1, wherein the two objects with initial velocity and towards each other in opposite direction. So our problem 1 states that a 56 kilogram ice skater traveling at 4 meters per second to the north meets and joins hands with a 65 kilogram skater traveling at 12 meters per second in the opposite direction. Without rotating, the two skaters continue skating together with joined hands. And so what is the final velocity of the two skaters? So for this problem, we need to identify first what is being asked, as well as the given. So the given here, we have number 1, our mass 1, that is 56 kilograms. And it has an initial velocity of 4 meters per second, while our mass 2 is 65 kilograms with an initial velocity of 12 meters per second. And so what is being asked here? We are asked for letter A. We have the final velocity. And for the letter B, it will be the decrease in kinetic energy. So we have kinetic energy decrease. And based on our problem, what will be our equation? So based on our problem, our equation will be, so number 1, since we're looking for the final velocity, we could have the momentum equation, and we all know that the momentum is being conserved. And so it will gonna be helpful if we're gonna write m1v1 plus m2v2 is equals to mass 1 v1 plus mass 2 v2. But don't forget that we have the initial conditions and we have the final conditions. So it will be helpful if we're gonna have added like the initial conditions and then we have the final conditions. Anyway, the mass wouldn't be changed because it is a constant. And so if we're gonna have now our solution here, so we're gonna continue now to our solution. So the mass 1 value is 56 kilograms multiplied to the initial velocity, which is 4 meters per second, and then plus, now we have to take note that the velocity 2i here is negative, which is negative 12 meters per second. Why negative 12 meters per second? Because if the case for letter A would be here traveling towards the north, and then it will be gonna colliding, so this one will gonna represent 4 meters per second, while the other one as an opposite velocity we're gonna have here the 12 meters per second. And so don't forget that this one is negative because it is in opposite direction. Now continuing, we have here the mass 1 again, which is 56 kilograms. However, we don't know the value of the final velocity, so we could represent it as Vf plus 65 kilograms, and again we have the Vf here. And so we may want to write it in this way, wherein the units are just being cancelled so that our equation would be neat. And so notice here that we could factor out the 56 the VF, so that would become 56 plus 65, and that would be VF. Okay, and then so for this one, 56 times 4, that would be 224. So 65 times negative 12, we can press our calculator, that would be 780. And so negative 780 plus 224, that would be negative 556, which is equals to 121 VF. And then by pressing our calculator, that would be negative 4.59 meters per second. So this will be our answer for letter A. Now you might be wondering, what does it mean for a negative here? The negative here, it means that for the two objects, they had collided, and then they are traveling on the southern direction. So notice here that this one, it has a very high speed, negative 12, and so that direction would be going southward. Now, how about when we talk about the question for letter B? So we may now go directly with our equation, and since we're looking for the value of our energy here, we could say that the formula for energy before, same formula, before and then after, kinetic energy before is equals to kinetic energy after. But since this one it is being collided, so this one is an inelastic collision, so that would be kinetic energy loss. And so we have here the 1/2, don't forget, m1 v1 square plus 1/2 m2 v2 square equals to 1/2 m1 v1 square plus 1/2 m2 v2 square plus the kinetic energy which is being lost. Now, it is an option notation that if you could have here your initial, so you could write I here so that you will not be confused. But it's okay if you don't write it anymore. You just write the condition for before and after. So you could write here the final, and final. And so we can now proceed with our equation. So we have here the 1/2. The mass one is 56. And then 4 meters per second, so we're gonna square it as our velocity. So this one is our condition, plus, so for this one, 65 kilograms and 12 meters per second. So we're gonna have 1/2 of 65, and that would be negative 12 square. So in terms of energy, negative will be unnecessary because that would be cancelled, and since this one is square, and then 1/2. And so our mass one here is 56, right? And then we already computed for the velocity here on the first part, which is negative 4.59. So you can write here negative 4.59 square plus 1/2 65, then 4.59 negative, then square it. Of course, plus kinetic energy loss. Okay? And so computing here for this one will become 448. Put the pressure calculator. 12 square is 144 times 65, then divided by 2. That would be 4,680. And then this one is 589.91. And then this one is 684.71. And of course, plus kinetic energy loss. Now take note that the unit of this, if you're going to look at the unit of this one is in kilogram, this one is in meter square per second square. So the unit, all of these will be joules. Okay? And so we could have here 5,128 joules. And then this one is 589.91 plus 684.71, that is 1,274.62 joules. Of course, plus kinetic energy loss. And here, we're going to have kinetic energy loss. And that is 5,128 joules minus 1,274.62 joules. And so overall, the kinetic energy loss would be 3,853.38 joules. Okay? And so if you're gonna look on this problem, take note that this kinetic energy loss, it could be anything, like it could be transmitted as a heat energy, internal energy, or it could be a sound energy. And so that's it for case number 1. You may work on your problem number 2 for case number 1.